Standard 8 Maths Chapter 1 Rational Number. Hello everyone, in previous video we have studied about the property of associativity. I hope it will be clear to you what is closure means, what is commutation means, what is associativity means, and how the property of commutation and association are being utilized in questions to solve the questions easily as compared to the normal method. In this video, we will continue with small topics like additive identity, multiplicative identity, additive inverse, multiplicative inverse, distributive properties, and like what is additive identity. Additive identity. Now, additive identity, suppose for a number A, additive identity is that number which when added to A will give the same result. What it means, which when added to A, if we suppose we are adding I, we'll take I as additive identity. When I is added to A, it should give the same result. So what do you think could be the additive identity? Yes, it will be, obviously it will be 0, because if we add 0 to any number, it will give the same result. So 0 is a additive identity. 0 is the additive identity. For whole numbers, for integers, and for rational numbers as well. 0 is the additive identity for whole numbers, for integers, for rational number also. Now we can take few examples, like take any whole number like 7. If we add 0 to it, what will become 7? We'll take an example of integer, say -3. If we add 0 to it, answer will remain -3. If we add 0 to a rational number, what will become? Answer will be 1 by 2. So additive identity of a whole number or integer or a rational number is that which when added to the original number, it will give the same result. So therefore we conclude that 0 is the additive identity for rational numbers, for integers and whole numbers. Now similarly there is multiplicative identity. What is it? Multiplicative identity. We have multiplicative identity. It is same as case of additive identity, but the difference is multiplicative identity of a number is that number which when multiplied to that number, answer will become same. Answer will remain same. Suppose there is a number A. What number we should multiply to A so that answer will remain A? So can you guess? So it will be 1. Because if we multiply 1 to any number, answer will not get changed. Okay, answer will not get changed. So 1 is the multiplicative identity. 1 is a multiplicative identity. Now, for rational number, it is okay. So rational number includes 1 by 2. We multiply by 1, answer will be 1 by 2. 3 by 17, we multiply 1, answer will become 3 by 17. So for all rational number, 1 is a multiplicative identity. Okay, which means if we multiply any rational number by 1, answer will not get changed, or answer will remain same. Now can you say that 1 is a multiplicative identity for integers? So question is whether 1 is multiplicative identity. We can multiplicative identity for integers or not. Okay, we check -3. It is an integer. We are multiplying 1 to it. Answer will remain -3. We say -47. We multiply 1 to it. Answer will remain -47. 13. 13 is also an integer, that is positive integer. If we multiply 1 to it, answer will remain 1 by 3. Now, if we multiply 1 with 0, since you know 0 is also a integer, so answer will become same or different. It is different in this case. So when we multiply 1 to 0, which is a integer, answer will get altered or answer will get changed. So we can conclude that 1 is not a multiplicative identity for integers. 1 is not multiplicative identity of integers. It is same in case of whole numbers. Why it is same for whole numbers? Because whole numbers start from 1, 2, 3. If we are multiplying 1 with positive number, answer will not change. But if we multiply 1 with 0, answer will become 0. So, 1 is not the multiplicative identity for integers and whole numbers. Yes, if we talk about natural numbers which start from 1, 2, 3, 4 or positive infinity, 1 can be multiplicative identity for natural number. So, this is clear. 0 is the additive identity and 1 is a multiplicative identity. Now, there is additive inverse. What? Additive inverse.